Okay, and the way that we write it in summation notation is we use the sigma symbol, and the sigma symbol just means to add it up. We pick a different letter only because here I used n. I mean, it's going to be like a 7 or a 10 or something, but because I did that, I'm going to write k equals 1, and at the top to n, a sub k. And so let me just talk about what actually would go there. So this a sub k, what's going to go there is actually an explicit formula for finding the terms. What goes here is from term here to term here. Okay, and so this tells you what term to start with, and this one tells you what term to end with. Notice I just didn't say which numbers, okay? You have to actually find the terms, but this tells you what the term is that you're going to start with and the term that you're going to end with. And the way that I would read it is the sum of a sub k from 1 to n. Okay, so we're going to do two things right now. We're going to just take an example of something, and then I'm going to show you how to find its sum. And then I think the harder skill is taking a sum and actually writing it in summation notation. Okay, so let's evaluate the sum, and we're going to give the sum by the following summation notation. Okay, so what this tells me is I'm going to find the first through 5 terms, and I'm going to add them up. How I'm going to find the terms is I'm going to do the explicit formula 3k plus 1. So what would the first term be? Plug in 1. What's the first term? 4. Now I need to go to term 2. What's the second term? Now I need to go to term 3. What's the third term? 10. Fourth term would be 13. And what would the fifth term be? 16. Okay? But then the summation symbol means now I add those up. So would you add those up for me, please, and tell me what the sum is? Okay, so let's take one and see if you guys can figure out how to write them in summation notation, okay? And then we're going to talk about, there's formulas, shortcut formulas for finding arithmetic and geometric ones. So let's write each sum and summation notation. And notice, did I say to find the sum here? No, we're just practicing writing them, okay? So we're going to practice writing a couple of these in summation notation. Let's try this one. So we're not going to actually find the sum. We're going to just need some pieces for the explicit formula. So let's just review. We need to know where it starts. We're going to assume this is the first term. We need to know what term it stops at. Yeah. Yes, sorry. You're like, what happened there? All right, we got to find the last term. And then what did I say goes here? The explicit formula, okay? All right, so I'm going to use, or first of all, try to figure out the explicit formula. And I have some notes for these because is this arithmetic or geometric? It's arithmetic, right? Can't we find its explicit formula? All right, let's find it. According to your notes, how do you find the explicit formula for something arithmetic? It says a sub n, we'll call it a sub k here because I'm using k instead. A sub 1, which is 2 plus n minus 1 times d, correct? Alright, so but I'm going to use k minus 1 times d. What's d stand for? Constant difference. What is the constant or common difference? 3. Okay, let's simplify that so we have our explicit formula. We have 2 plus 3k minus 3. So this ends up being 3k minus 1. Okay, so let's do it. The summation notation, the formula would be 3k minus 1. And we do k equals 1. Uh-oh. What do I put at the top? Do I put 29? What does this stand for? This is the first term. So if I put 29 here, that wouldn't be this. That would be the 29th term. Can you guys figure out what term 29 is? So how did you figure that out, Joey? Yeah, did you put 29 in? Yeah, you could just look and say, okay, if that's the formula, let's figure out what k is. Add 1, you get 30, right? Divide by 3. Okay. There you go. So that would be the explicit formula for that one. How we doing? Did you guys do summation notation? Did you write summation notations last year a little? Okay. Let's do one that's not arithmetic, where really the formula is given to you in the problem, but we'll talk about how you do that. So the second one we're going to do is 1 plus 8 plus 27 plus ... n plus 1 cubed. Okay. Now, here's the nice thing about this. I've really given you the explicit formula already because I put it here at the end in terms of n. So what I'm saying is how I'm finding these terms is I'm taking the term number, I'm adding 1, and then I'm cubing it. Okay? Well, I just want to check out. I'm going to put that here then. K plus 1 cubed. Okay. Let's check it out. And also the nice thing is then, I know where it stops because it stopped at n. It told me that it stopped at n. Alright, so this is 1, right? Well, let's check it out. What's 1 plus 1? 2 cubed. Is that what you see here? Nope. So how can I adjust my notation to make it start at 1? What are some things I could do? Yeah, let's start at 0. Would it work with 0? Let's see. What's 0 plus 1? 1 cubed. Perfect. Then I'd start with 1 would be this one and so on. Okay? Anybody else see a way that I could change this formula around? There's more than one answer to this. Okay, good. Carmen said, take away the plus 1 and make it k cubed, and then start it at 1. Now, be careful then, instead of ending at n, I'd have to end at n plus 1. Both of those are valid ways that you could write that. Okay? Okay, then the last thing that we're going to talk about today is just how you actually find the sum of something arithmetic. So, we're going to do geometric as well. Would you guys get out your note page from yesterday? Not your note page, your formula page.